So today's lesson is going to be on one-step equations, just like lesson 26, only today we're focusing on multiplication and division. So you're not going to see any addition, subtraction like yesterday, just your multiplication and division for today's problems. So it's the exact I can statement from yesterday. It's I can solve one-step equations by creating a diagram and checking to determine that the equation is true. If you're not checking, you're redoing your work. Remember, with that create a diagram, that means we're going to be having some kind of picture support. And again, just like yesterday, you're going to be able to probably solve today's problems in your head. However, for 7th grade, you need to be able to model and check your work. So we're getting you ready for 7th grade. Alright, we're going to start with the exact same phrase from yesterday. Our right side must equal the left side. So get some way to remember that. My right side must equal my left side. You can draw arrows to help you remember. You can get that written down in your math notebook, but whatever you can do to remember. Okay, so we're starting with the same thing. My right side must equal left side. And here's our new problem right here. 3 times z equals 9. It's asking us to solve using tape diagrams and algebraically. And then finally, we're doing that checking our work. So first, I'm going to do that tape diagram. So what I need to do, I need to draw a tape diagram for my right side. So I draw a tape diagram, a bar, and how big is it on the right side? When I look at my equation, remember it has 2 parts, a left side and a right side, and my right side is just that 9. So I draw my tape diagram, I just label it 9. Nothing else important. So I made a tape diagram of 9 and I did that labeling. So here I have a more precise one. Now I need to make that model of my left. Remember my phrase, the right side must equal the left side. So how big is my left side going to be? Well, it's also going to be 9 because remember that left side has to equal that right side. So we have that picture show that they must equal the exact same thing. So this is our tricky part. 3z, what does that mean? Well, I know that it's going to be 3z because that's all I have on the left side. What this is telling me is that there's 3 groups of z. Remember, when I'm multiplying, I'm making equal groups. So that's telling me that there's 3 equal groups. So what I can do is I can label it 3z, or I can rewrite it and I can break it up into 3 equal groups of z. So here's 1 group of z, 2 groups of z, 3 groups of z. 1, 2, 3z, that's the exact same thing as 3z. So now I can ask my question. I have 3 equal groups, they're each z. How big would that have to be? So let's look here. If I have 3 equal groups and together they equal 9, what would that be? Well, I know if I have 3 for one, 3 for the other, and 3 for that, that's 9. 3 plus 3 plus 3 equals 9. There's still all equal groups because all 3's are equal, and that's going to give me that answer of z equals 3. I can draw that picture to show as well that this z is the same length as this 3. So now I'm going to solve it algebraically. So that's that phrase, whatever I do to the left side, I have to do to the right side. So it's going to be focusing on that inverse. Whatever inverse I do to the left, I have to do to the right side. So here I have 3z equals 9. 3 times z equals 9. Well, what is my inverse? I know that I'm multiplying. Remember, if I don't have any operation with the variable, that means I'm multiplying if that variable is right next to the number. So what's the opposite of multiplication? That's division. So I'm going to divide, and I divide by whatever that number is. So here I'm dividing by 3. Remember that fraction bar is also division, so I'm dividing by 3. I divide by whatever number is next to my variable. And then whatever I do to that left side, I have to do to that right side. So what I'm left with is z equals 9 divided by 3, or 9/3, and that's 3. For those of you who are curious why we do that is, remember yesterday when I would have a problem like a plus 2 equals 4, and I would do the inverse. I subtract 2 because I'm trying to isolate that variable. I'm trying to get it by itself. So I'm actually left with a plus 0 equals 2, and then I can get rid of that 0 to get a equals 2. I'm also trying to do the same thing with my division and multiplication. I'm trying to isolate that variable. So if I remember from multiplying fractions, 3 times z divided by 3, I know that 3 divided by 3, that's 1. So I'd be left with 1 times z, and I can rewrite 1 times z as just a z. So I've isolated, made that variable all by itself. Did that answer z equals 3? Was that the same thing that I had for my tape diagram answer? Let's check. Yeah, they're both 3, so I'm pretty sure my answer is z, but I'm not finished yet. I have to check my work. So how I check is I rewrite my problem, then I substitute my variable in. So I said z equals 3, so I'm going to substitute that 3 in. So instead of 3 times z, it's 3 times 3. And does 3 times 3 equal 9? Well, I know 3 times 3 equals 9, and I know 9 equals 9. So my answer checks, so I know my answer is correct. All right, this one's a little bit harder. It's division. So let's focus on it. We're doing the same thing, tape diagram, and solving algebraically this expression. Y divided by 4 equals 2, and then I check my work. I check my answer. So first I make a tape diagram of the left side, and I'm going to make a tape diagram of the right side. Well, how big is my right side? I start with the side without the variable. It's just easier for me. So I draw a tape diagram, and I label it 2. It's telling me that it is too long. How big is my left side? Well, that is y divided by 4. I just replaced that fraction bar with the division sign. Remember, they mean the exact same thing. Now, I think I'm stuck. What do I do next? Well, remember, when I'm searching with expressions that involve variables, I'm always looking for what does y equal. Here I don't know what y equals, so I have to do something a little bit different with division problems. What I need to do is I need to figure out how big is y. Well, this is telling me I have some y, and I'm dividing it into 4 equal groups. So that's telling me that I have some amount y to start with, and I'm dividing it into 4 groups. Because I see y divided by 4, so that's telling me I have a y, and I divide it into 4. So now I'm going to ask myself, how big is this section? Well, I don't know because there's a y here, but what I do know is I have a y divided by 4 because I divide into 4 equal groups. And when I divide into 4 equal groups, that means they're all going to be the same amount. So we're going to look on the next page. It has it a little bit easier laid out, nice and tidy. We know that y divided by 4 equals 2 because I have that picture right here. It's the same picture we have over here. They're equivalent. They're the same. How many groups of y divided by 4 do we need to make a whole y? Well, here I have that picture here. I need 4 groups. 1 group, 2 groups, 3 groups, 4 groups to make this large y. Remember, I'm always looking for that y equals. So it's the exact same thing we did with this part down here. How many groups of my variable do I need to make the exact variable? How many groups do I divide that variable up into? So here's all that information that we have sketched so far, that we've drawn. Y divided by 4 equals 2, and then 4 groups of y divided by 4 equals y. I want you to look and see if you can figure out what the answer is. Remember, we're always searching for what does our variable, in this case y, what does y equal? Take about 30 seconds, see if you can figure it out. Okay, about 15 more. Okay, if you said 8, you would be correct. Look at this, 2, and then I'm going to copy and paste this 2. And I want you to notice what is happening. remember, this 2 is the same as y divided by 4. So I can line them all up, and I see I have 2 is the same as y divided by 4, 2 is the same as y divided by 4, 2 is the same as y divided by 4, and 2 is the same as y divided by 4. So now I can look, hey, I notice they're all the same length, so that means they're all equivalent. I don't know what y divided by 4 is. Oh wait, it's the same as 2. So I can now count 2, 4, 6, 8. So this whole length is 8. Since they're the same length as y, I know that this is also going to be 8 because that 2, 4, 6, 8. So what does y equal? It equals 8. But we're not done. We need to check it algebraically. So what I do first to solve algebraically is I perform that inverse. So here my math operation is division. So my inverse is that multiplication. So I'm going to multiply, and I multiply by whatever number is by the variable. So here I see this 4 is by the variable. So I'm going to multiply by 4. What's my next step? Well, my next step is that whatever I do to the left side, I have to do to the right. What did I just do to my left side? Well, I multiplied it by 4, so guess what? I have to do the exact same thing to my right side. Multiplied by 4, so I need to multiply by 4. My last step is I'm just going to solve it. Remember, these 4's cancel out. It's the same as 4 divided by 4, so I'm left with this y equals 2 times 4, which equals 8. So I'm left with y equals 8. Is that the same as my tape diagram? Yes, it is. But I'm not done yet. I still have to check my work. So my first part for checking my work is I rewrite the diagram. Oops, this looks like it is the wrong problem. So I'm going to check my work on this part. So how I check my work is I said y equals 8, and I rewrite the problem. Y divided by 4 equals 2. I substitute in 8 is the same value as y, so I put 8 in for y. And then I check, is 8 divided by 4, what is that? Well, 8 divided by 4 is 2. Does 2 equal 2? Yes, it does. My answer is correct. Alright, let's take a look at this problem. We're going to do the same thing, solve it with a diagram and then solve it algebraically. So I have 2 times a equals 16. So my first step is I'm going to create that tape diagram of the left and right. My left side is 2a, my right side is 16. So they're going to be equivalent, be the same length. Here is my 16, here is my 2a. Remember, 2a is just repeated addition, so it's a plus a. I don't know what my a equals yet, so I need to do my next step. What plus what would equal 16? Well, I know 8 plus 8 equals 16, so then I'm left with my answer of a equals 8. I know a equals 8 because they are the same length. Okay, now I'm going to check it algebraically. My first step is perform the inverse. So what does that mean? Well, it means that I'm going to see what math operation I'm doing here. I know it's multiplication because I know 2 next to a variable is multiplication. So my opposite, inverse means opposite, is I divide. So I'm going to divide 2 times a by 2. My inverse, and then whatever number is next to that variable. My next step is whatever I do to the left, I have to do to the right. So I divided my left side by 2, so I divide my right side by 2. My last step is solve. So remember, my 2's are going to cancel out because they will equal 1. So I'm left with a equals 16 divided by 2. I know 16 divided by 2 is 8. My last step is I need to check my work. So I know a equals 8. It's the answer I got algebraically and with my tape diagram. So I rewrite my problem, and then I'm going to substitute. So this a becomes that 8. 2 times 8 equals 16. And then I solve. Well, I know 2 times 8, that is 16, and 16 equals 16. So I know my answer is correct, since the left side equals that right. All right, this is going to be our last problem. I'm going to have you guys attempt to solve some on your own. So here I have b divided by 3 equals 4. I'm going to create a tape diagram on my left side and the right side. My left side is b divided by 3. My right side is that 4. So here is my left, b divided by 3. And here is my 4. Remember, my left side must equal the right side, so that's why they are the same length. Do I know what b equals yet? I don't. I know what b divided by 3 equals. That equals 4. But I don't know what b equals, so I need to think, what can I do to show what b is? Well, I know b is going to be larger than b divided by 3. Whenever I divide something, it gets smaller. So I know b is going to be a larger number, so I draw a larger tape diagram. And then I need to ask myself, how many groups did I divide b into? Well, I see 3 here. It says I divide it by 3. So I know b divided by 3, I'm going to have 3 groups. Here's 1, 2, 3. Since I divide it by 3, I need 3 groups of b divided by 3 to make a whole b. Now, how big is each b divided by 3 group? Well, I look up here. This is why they need to be the same size. I know b divided by 3 is the same size as 4. So I can now add that part to my fraction bar. b divided by 3 is here. I know it's the same length as 4, so I can now substitute, and I'm left with b, my giant fraction bar, or my giant tape diagram, is the same as 4, and another 4, and another 4. So what is that? Well, 4 plus 4 plus 4, that is 12. So I'm left with b equals 12. I know that since b is the exact same size as my 12. Am I done? Nope, I'm not, since it says I need to check it algebraically just to make sure this is the right answer. So my first step is I rewrite the problem. Then I perform the inverse. I look, what do I see for my math operation? I see a fraction bar, so I know I'm dividing. So I'm going to do the opposite, which is multiplication. And so I look, what did I multiply by? I'm going to multiply by whatever number is on the same side as my variable. So here I'm multiplying by that 3. My next step is whatever I do to the left, I do to the right. So I look up here, what did I just do to the left? Well, I just multiplied by 3. So what do you think I'm going to do to the right? I'm also going to multiply by 3. And then my last step is I solve. These 3's cancel out. So I'm left with b equals 4 times 3. 4 times 3 equals 12. Am I done? Not yet, since it still says check your work. So my last step for check my work is I know b equals 12 for my tape diagram and by solving it algebraically. So I'm going to rewrite my work, substitute in 12 divided by 3 equals 4, and then I solve. 12 divided by 3, that is 4. 4 does equal 4. Alright, if you are working on the computer, I'm going to have you skip the poster creation. You're going to skip the carousel, and you're going to follow these directions. Your directions, though, are going to be a little bit different. I want you to complete all of the problems. This says remaining. You're going to complete all of the problems on Socrative. When you're finished, go to AAA Math. I will have told you at the beginning of class which AAA Math you're doing. And then after you've solved 50 problems on AAA Math, and I've seen it, then you may go to Math Games. Alright, have fun on your Socrative.